Welcome, a very warm welcome to everyone from ITNEXT in association with Juniper Networks. We'll be starting today's session. Thank you so much for joining us today. Today's topic is Build the Campus, Build the Future. So mobile technologies and smart devices are now allowing people to work from anywhere at any time. So the enterprise network needs to be always on and always available. The network of the future will also need to enable new kinds of workflows and collaboration, handle large volumes resulting from streaming video and interactive applications, be flexible enough to be scaled on demand, and finally, the network will need to facilitate robust security while being reliable and resilient. This is exactly what today's speaker, Mr. S. Rajkumar, will be speaking about. He has more than 15 years of experience in networking. He started his networking career from Nobel and then moved on to companies like HCL, Siemens, and Nortel. Now he's working in Juniper Networks as a senior technical consultant. In his role in different companies, he has designed solutions for enterprise, government, and defense customers. Some of the key design and solutions provided by him are for the Delhi International Airport, Command Networks, One Network, Data Center Solutions, etc. He has won many awards. One of them is for designing the One Network for Army. His hobbies include reading, hearing music, and playing shuttle and watching MotoGP and F1. Now I would request Mr. Kumar to take over and start his presentation.
Thank you, Varun. Good afternoon, everyone. Thanks for joining. As Varun was explaining that today is the topic what we are going to cover is build the future, build the campus on enterprise, right? Always on. So what I wanted to say here is today, when we see the enterprise networks, campus networks, the trends are changing rapidly, right? So when we have to build the campus networks or the enterprise networks, we need to know the trends which are happening today in the market, and the networks what we are going to build should be able to take care of the future technologies which can be adapted onto this kind of campus networks, on this campus network. So moving to the next slide. So today, if you look at it, the network industry is an exciting place to work, right? Because there are three major inflation points that drive the need for high performance networks. If you see on the slide, you can see there are three inflation points which are happening today in the any enterprise or any kind of a campus or any kind of a network what we look at. One is the mobile internet, the second is the cloud services, and the third is the collaboration and the content. That means the videos, right? So what happens is, if I look at the mobile internet is exploding. Gartner is predicting that a billion smartphones will be shipped this year. And also, if you look at the cloud adaptation accelerating, right? 80% of new enterprise apps are now deployed in the cloud. So the growth of video is not only changing network traffic, it is changing the very nature of the network itself. So if you see, there is a lot of video content which is streamed across the enterprise or the campus network today. It was not like earlier. What we used to see is just the data flow, or it is just a mail transfer, or applications which are used on the network. Today, the video is extensively used, right? So the nature of the video itself will enable you to change the network scenarios and adaptation what is required on the campus network, right? So what is the prediction is by 2015, 60% of the traffic will be streaming video, right? So when we see this, these trends are happening parallelly. It is not like only one or the other is going to actually explode. They are exploding parallelly, right? So that what happens is, once this happens, then the customers who wants to build a network are looking at how to deliver. The first problem comes in is the security. When there is a explode in the traffic, when there is a lot of video content running on the enterprise networks, and there are apps which are built for the cloud services, and also you are using mobility like BYOD, people accessing the applications anywhere, anytime, then the security is one of the key concerns what they are looking at. And also they are looking at is how to reduce the cost, right? Once we have to adapt to these kind of trends and build the networks, then what is the like how do we can reduce the cost? Manageability, right? How simple is it to manage? And also to enable new services which they may be looking at in near future. So these are some of the key changes and which are rapidly changing, and we are all aware that these are the facts and these are the real scenarios which are happening in and around us today, right? So there is no second thoughts in saying that we don't use BYOD or we don't give access to employees who come from anywhere to access the applications. And today cloud services have been adapted, and also a lot of video content is being running over the network. So that is what we say, that the innovations needs to take place in terms of looking at the solutions, in terms of the OEMs building the campus solutions which can take the future requirements as well as to provide high performance networks to accommodate these kind of trends and inflation points which are happening. Then if you look at the next slide, right, this is the slide. If you see here, there is a lot of network chaos happening in the enterprise networks, right? If you see, there are people, there are devices, there are applications, there are data which are being transferred across the network. So there is a huge bandwidth explosion happening. There is a lot of multiple devices which has diversity of devices which are coming into the network. As I told earlier, the security compliances are the key. Who is coming into my network? Who is accessing what applications? He is the one who should be allowed into my network, right? The compliance part of the security, those criticalities also creates network chaos, right? Because there is a lot of, actually what we see, if you see in the slide, you can see there is a storm actually building up because of this kind of devices, apps, data, and people accessing the network. What this storm is creating is the bottleneck of the network, right? The bandwidth usage, which creates a lot of bottlenecks and also creates a poor performance and slows down the network. So what happens is you may fix this bottlenecks whenever you want to have, whenever you see some bottlenecks, you may fix those patches. But if you want to scale tomorrow, or you want to be flexible and the network has to be agile, then this patches and what we do, minor patches to the network, will not help when you want to look at the future services what you have to bring into the network. So what I wanted to say here is that this is what we are looking at from the campus and the enterprise network. There is a chaos happening, and there are a lot of devices, apps, and data which is accessed by the people, like what we can call it as BYOD or MTM, mission to mission. Those kind of traffics are increasing. It is creating bottlenecks, and also it is creating the network to slow down. So this is what is happening in terms of the network chaos. So what I say is, the next slide I move to, what I say is, this is the enterprise, right? So you can look at from the manufacturing side, or you can look at from the healthcare or from the IT. This network chaos is happening, and there is a lot of bottlenecks being created because of the video content, because of the cloud services, right? Because of the mobility in place. So what I say is, you can't actually pinpoint that only certain kind of IT or certain kind of manufacturing is having these problems. It is throughout across the enterprise where they are seeing these kind of issues which are coming up, and the customers are looking at low cost, high availability, high performance, and good security in place, right? So what I say is, if you see the slide, so the enterprise extends far beyond the confines of the company, right? So what it says is that if you see this slide, you can see there is a lot of multiple levels of transportation, congestion happening, tower building. But what I wanted to say here is that its organization is not confined to a building today, as per the network perspective, right? All business lives, what we call it as. You may be with your customers, you may be with your coworkers, it may be between mission to mission like printers or video cameras or surveillance. So all these are actually what we call it as an enterprise or a campus network. So this is so what I wanted to give a message here is, don't think that campus network means it is confined within the building. It's not so today. It is geographically distributed. You have multiple devices communication happening, multiple data across the network, video, anytime, anywhere access. So that is what we say, that is how you need to look at when you look at the campus networks. So it is not that it is confined and I can build a network which is within the building and I can give the access to the users and they will be happy, right? So that is what I wanted to say. And in the next slide, what we say is that today the campus or the enterprise is not a place you go to connect, right? You take it with you wherever you go. So what we say is the enterprise should be always on kind of a solution. So today it is not that the employee comes, sits in the office, accesses the application and then goes out. But he may be anywhere. He may be with his customers, he may be with his distributors, right? But he wants to access those applications anytime, anywhere. So that is where what we say is that the network should be available for this employees who wants to access the apps from the cloud services or from the data center, right? So if you look at the trend, what is happening in the enterprise market, in the enterprise networks today, right? So we see in 2013, the wired and wireless was approximately 50%. And as we move on, in 2015 to 2016, we see that the wired connections is around 30% and the wireless connectivity is increased 20%. This is the IDC report, right? So the higher density is on the wireless rather than the wired, correct? So this is what we call it as. Why this is happening? Really, you should ask a question: why this kind of actually inflation is happening on the wireless side rather than the wired side? Because it provides services to a higher density of devices than wired can provide. One access point can connect to around 15 to 20 devices or 15 to 20 laptops or 50 to 20 people, right? Or the cameras. So that is where the wireless inflation is happening. And also the machine to machine communications are increasing. As I have written here, like the printers, the projectors, the cameras, the sensors, all are coming with wireless. So they are all Wi-Fi enabled devices. So the connectivity, what they require is primarily on the wireless. And the second point is that they also look at the same quality of service, the same availability, the reliability required on the network to access those applications and provide those data to for either for analytics or forensics or to monitor whatever you want to, right? So, so what I say is today you can't separate the wired and the wireless. It's a unified network which has both wired and wireless put together as a network. So the network transformation, right? If you see this network transformation, today unified communications and collaboration applications are increasing. This is because the way the companies want to communicate effectively and also they want to communicate faster and also they want to do it efficiently. All these are the key requirements of any enterprise network. And added to it, they want to save the cost of the travel, right? So with this, what you need is a high density traffic because the collaboration requires a lot of key features to be enabled on the network, like low jitter, high bandwidth, guaranteed QoS. So these are the key requirements from the operational perspective where the network has to provide to if you want to enable the employees with unified communication and collaboration, right? So that is what is happening. So there is a major shift which is happening, what we see from last 18 months of the enterprise networks and today, right? So there is a lot of requirements what they look at from the network perspective. So they are transparent to those networking infrastructure, but the networking infrastructure is the key which provides all these capabilities to the user who wants to access any application or any collaboration what he wants to do over this network. So that is why we say build the future so that it can adapt to this kind of requirements what the users are looking at, but at a lower cost, at high reliability, high performance, and good security. Correct. So the other challenges what we see when we enable unified communications is that the access network and the wireless network should be collaborated, right? And also what we see is if you take a Microsoft Link today, it has all the capabilities, right? But they also ask for these kind of features on the network. You can do voice, you can do video, you can do chat. Today you can do desktop sharing, right? But the key requirements, what they look at is the low jitter, high bandwidth, guaranteed QoS, and high availability kind of a scenario. That is not only from wired, they also look at from the wireless network perspective. So that is where we say that the network should be unified. The network should have capabilities, whether it's a wired or a wireless, to provide the same kind of availability, the same kind of response to the user, whether he's on a wired or whether he's on a wireless. Right. So looking at all those trends and looking at those rapid changes happening, and also the applications which are driving the network requirements. Earlier, we used to build a network and put the applications on it, but today, the users, there are so many apps and there are so many applications, the video, all those machine to machine communication. So the infrastructure is becoming the key, and the network or the infrastructure has to adapt to provide these kind of functionalities or these kind of capabilities to the users at the end of the day, right? So the infrastructure is becoming more critical. So that is what I just wanted to say here, that we need to look at the infrastructure in a better way, in a positive way. So from Juniper perspective, what we are saying is that we are enabling IT transformation. So what we call this is always on network. Whether the network has multiple devices, there may be multiple applications, there is a huge data running across the network, and there are more and more people who are accessing these applications and data and the video services which are running on the network. But from the network perspective or from the infrastructure perspective, it should be always on. So this can be provided only if you can think of building a network which is reliable, which is simple, and which is secure, right? Otherwise, what happens is you may build a network, but you may compromise on any one of the parameters. Like you may say that I don't need to have high reliability, but I want the network to be secure. But that doesn't mean that you don't need reliability, right? Because if the network goes down, then no one will have access to any of the applications, right? And also from the simplistic way, we should see that the network which we build should be also simple so that it is easy to manage and it is easy to scale and it is easy to adapt to the future trends which we see in the market today, right? So moving on to the next slide. So this is what we call it as Juniper Networks on Enterprise. So we have the complete switching, wireless LAN, and network management solutions that provides the complete capabilities to build a campus network which is highly reliable and simple and secure. So what we say is today's workforce is elastic and fluid, right? Today, why I have put this picture is it is not, as I told earlier, it is not bound by walls or geography, right? It depends on constant and secure access to the corporate network and applications from any device, anywhere, at any time. So what we call it as on enterprise is a reliable, simple, smart network for people, devices, and things. So enabled by a comprehensive portfolio of switching, wireless, and management products, which can provide you consistent, secure access to business critical applications. This is what we are driving in terms of the campus networks or in terms of the enterprise networks, what you call. So there is no geography, there is no walls, there is no confined areas, but now the campus network can be looked as if they are very elastic and fluid, and they need to have these characteristics of the network, right? So getting on again, so if you see this slide, this is a very interesting slide, right? So on the x-axis, you can see the trends which are happening, and on the y-axis, you can see the connectivity and also how Juniper is adapting to these trends and building and coming out with some of the greatest innovations, right? So if you look at it, Juniper has moving along and at times ahead of the market to meet these key trends and drivers. So we have a remarkable history of innovation when it comes to connecting everything and empowering everyone. So if you look at from 2010 to 2013, the way the trends have changed, whether it's a first iPad or a LinkedIn or a Facebook, so the unified policy, wireless coming into play, the unified network, right? And then also having kind of unified collaboration applications which are coming onto the network, and also what we call it as, I don't want to say much on this, but what we call it as the SDN, which is taking off. You might have heard of SDN networks, which are being a buzzword today. So all this are related in terms of the trends and in terms of the OEM or the Juniper, which is trying to actually innovate as per the trends or move ahead in terms of the market, in terms of trends and the drivers. So what we say is, when we say on enterprise switching strategy is, that is what I said: reliability, simplicity, and security. So reliability means how reliable, what is the availability of my network primarily. Reliability means. So what we say is, when we look at this, there are a lot of things. They may be very small things, but it matters when you build a campus or enterprise network. If I have few management points to manage, then it becomes very easy. In-service software upgrade. That means when I want to upgrade or when I want to do a patches upgrade or a full one OS version to another version upgrade, then the network should not go down for certain amount of time and then come back, right? It should offer the services parallelly. It should get upgraded, right? And also today, a lot of analytics and dynamic optimization is required. How do we log? What is the analytics what we want to do? Or how do we monitor the users? Who is using what applications? What is the bandwidth is hogging? Are there right people who are coming into the network, right? These are the things which we need to take care. In terms of simplicity, if we can, today I said the unified the collaboration and all this leads into a complex kind of access, complex kind of requirements which are required on the network. But if we can make it simple for the users so that they get the required applications and they get the required bandwidth and the guaranteed QoS what they are looking for. So how simple we can make the network architecture so that it becomes very easy for the IT administrators as well as for the users to access the applications. At the end of the day, then security is the key, wherein there is a lot of new innovations are happening in terms of MACsec and also in terms of logical partitions is required in the enterprise and the campus networks. Like there may be multiple projects, so they want to have a physical network being split into logical separation so that they can run their own projects with their own requirements, right? So these are the key things which we are looking on a strategy. So first I'll cover the reliability part in terms of the Juniper, how we are defining the reliability as one of the key things in terms of the campus networks. So bringing reliability. So if you see the problems now today, what the customers are looking for is ubiquitous connectivity, right? And today the connectivity is not just 10 gig or a 1 gig kind of a connectivity. They are looking to support, the network should be able to support voice, video, data, and real-time applications across multiple locations and geographies, right? And also deliver an optimal user experience. That is the key. Consistently over wired and wireless networks. Improve productivity of workforce, collaboration, and unified communication. These are the key requirements of the customer. So when they look at this, then the reliability is the key, and the seamless location agnostic access across the converged wired and wireless network is the key. So ability to innovate and support this expansion comes from the case being able to optimize time to deliver and being agile enough to deliver. So the network should have agility, the network should have the capability to optimize, and also the network should have the capability to expand, right? So these are the key things. And if you look at the solution, what we have the complete thing at MPLS being deployed in the enterprise network. like it may be L3 VPNs, it may be L2 VPNs stretched across two different locations, or it may be what we have a concept known as virtual chassis, or at the high reliability perspective, they need to have two core switches so that if one of the core switches fail, there is a second core switch to take over. And as I explained, the in-service software upgrade, wherein you don't have to bring the network down to upgrade your systems. So the benefits what you get from this is a continuous service delivery on a single unified network. When I'm talking about this ISSU, when I'm talking about this reliability, don't think that it is only for the wired. What we are talking here is wired and wireless put together as a one unified network, right? So one of the examples what I have put here for the reliability perspective is one with a horizontal closet and another is a vertical closet. If you look at here, on the left hand side, there is a closet 1 and the closet 2. So there, if you see, the laptops or the PCs or the printers or the cameras can be dual home to one of the closet Ethernet switches, right? Even the access points. And then they are combined to form a single logical system per closet. So I don't have to manage each and every switch. And the second point is, even if one of the top switches fail, the rest of the switches are active and it is dual home so that the traffic can go through the second switch, right? So first is the reliability, the second is the management perspective. Then these closets are dual home to the aggregation or the core switches, right? So once they are aggregated, so even if one of the switches fail, there is another path to go through the network. So there is no single point of failure, what we say, in terms of building this kind of a virtual chassis kind of a solution, right? So if you look at on the right hand side on a vertical building, so the devices, the building A and building B, if you look at it, so there are a lot of switches which have been put in the virtual chassis. That means they are clustered together to act as a single logical system, and then they are dual home to the core switches, and at the bottommost EX9200 VC. So you can create two core switches as a single virtual chassis, wherein if one of the chassis fails, the other chassis will take over and provide the services for the users over the network. So if you see these diagrams, you can see whether there is a lot of flexibility and agility to connect the devices and to build the network and also provide very high reliability. That is the key. So one point is that if you see the access, they are all connected together in a virtual chassis, and devices are dual home to this virtual chassis, and these virtual chassis are again dual home to the core switches, and the core switches are also created as a virtual chassis so that they have a dual redundancy in terms of the core perspective. So at the end of the day, you see that there is no single point of failure. Either a switch fails, either a ring fails, or either a core switch fails. So this is something unique what we do in Juniper, because don't confuse this with a stacking, because stacking doesn't give all these capabilities. Because if you want to upgrade the software, you upgrade on one switch and rest of the switches are upgraded by the master switch. So and rest of the services will be running. And if one of the links fails in less than 50 milliseconds, the rest of the links will take over. One sec, I just got this. Okay. So moving to the next slide, this is what I was talking about, deploying MPLS in the enterprise network. So if you have three locations which are across the cities, and for example, you have a finance guy sitting across these three locations, and you have R&D guys who are sitting across these three locations, and as well as market, then with the MPLS kind of a solution, if you see this diagram, then the finance guys can sit in site 1, site 2, or site 3. He may be agnostic about this complete network, and then he get the seamless access to the applications what he is supposed to get. He may be a financial guy who is in site 1, but he has moved to site 3, but he will get the service and the same experience as he was sitting in site 1. So this kind of logical separations, so that the finance will not talk to R&D, R&D will not talk to marketing, and they have their own VPN being stretched across these three sites, and they get those applications and those services which are required for the financial partition, right? So this is what we call it as the deploying MPLS and VPN. For example, I will tell you in the airports, what happens is there is a lot of applications which are required this logical separation, like baggage management system, baggage handling system, the boarding kind of different airlines. So they need there to be a single infrastructure, but they want logical separation on the single infrastructure. So Jet doesn't want to talk to Indian Airlines or Air India, and they want a logical separation over this network. Then the best way to do this is using MPLS kind of capabilities, so that we can carry the only the, if you see the red one, the red VRFs, what we call it, across the all the three locations and put them as a single one unified network on a single infrastructure. The blue can be another VRF, which is for example, R&D, and they form their own network over the single infrastructure. So this is what we call it as deploying MPLS in a campus network. Today we see a lot of campus customers, enterprise customers deploying this kind of MPLS capability, right? So moving further, this is what I was talking about, multi-chassis LAN, right? So this is a thing which actually gives you the complete reliability if one of the core switches fail. If you see this diagram, the edge switches or the aggregation switches are dual home to both the core switches. So if one of the core switches fail, the other core switch will take over, right? It is just a lag or a 802.1 AD which is going to be configured on these switches. It is very simple, but it gives you very high reliability, right? And if you look at, as I was saying, it is a unified network. Now we need to look at the same in terms of the wireless, right? So the wireless also provides you the high reliability. So one is that if you look at the rightmost corner, the wireless are also dual homed, as I was saying, to the controllers. So if one of the controllers, wireless controller fails, then the traffic will pass through the second controller and it is hitless. That is the key, because we do something known as a wireless LAN controller clustering. That means the wireless access point will actually connect to the cluster rather than connecting to the specific wireless LAN controller. So if one of the wireless controller fails, then automatically it is switched to the any other controller which is available at that point of time. Okay, and also the RF technology. We have a lot of superior RF technology in terms of band balancing, what we call it, where we can have users going to 2.4 gigahertz and 5.4 gigahertz. We can distribute them, and the users can be load balanced across multiple access points, and the access points can be load balanced across multiple controllers, so that everything is load balanced across multiple devices, so that if one of them fails, the second one is there to take over the traffic and run smoothly and seamlessly without interrupting the users from accessing the application, right? So I just wanted to say this is something unique what we do it, which is known as in-service software upgrade. We do this for the wired, but I just wanted to put it that we do the same for the wireless as well. That means if one of the controllers is being upgraded, then the controller, what it does is it moves the users automatically to the second controller and it upgrades itself, and when it comes back, it pulls back the users back to him. So the users doesn't get disconnected from the network, or their services are not interrupted because of this upgrade. In the same way, the access point, when it is upgraded, it pushes the users to the second access point. Once the upgrade is done, it pulls back the users back to its access point. So whether it's a controller or whether it's an access point, so it's a hitless software upgrade, what we call it, without disturbing, without actually bringing down the network for the users. So this is something unique, and this is the same what we do in the wired network as well. In a virtual chassis, one of the master switches are upgraded, then the traffic flows through the rest of the switches, and once it is upgraded, it upgrades the rest of the switches. And in the same way in the core, we do ISSU, where one of the RE is upgraded, the other RE takes over, and once that is done, then the second RE is upgraded, and then they come up, and but the services are not interrupted. So these are some of the key things which we need to look at when we design the campus or the enterprise networks, right? So what I wanted to say next is there is reliability through customizable, what I can call it as the SDN, right? So in today's networks, it is difficult to provide a reliable, seamless experience across wired and wireless, right? So that is where we come up with something known as SDN or a open flow, what you have heard of. So connectivity across the converged network, and also what we do is simplify the management. The first step towards this is the simplifying the management across the campus network. I'll say how in the next slide. So what we have is something known as a Junos node unifier, right? So this is something, what we call it as a platform program for MX that reduces the equipment and the cabling, right? So what happens is if you see the switches which have been clustered, so the MX actual switches will form as a part of the MX at the core level. We call it as a satellite nodes, so that these satellite nodes will become a part of the core switches in the network. So whenever you want to upgrade, it is like a line module sitting inside the core switch, but they are extended across the campus. So now you can see how easy it is that whatever we want to configure, we can push the configuration from the central core switch to all the switches across the campus network. We don't have to go to each switch and configure the parameters. It is pushed through the central core switches, right? And also if you want to upgrade the switches, then it is done centrally by the core switches. And also you get all the monitoring alarms, logs, everything at the central core switch where you can analyze and find out where the problem is. So at the end of the day, you don't have to test these satellites which are spread across your campus. You can completely maintain, manage, configure, and do the analytics sitting at one central location. This is known as node unifier, which is unique. And next slide tells you how it is, right? So there is MX, there are satellites which are connected to the core switches. So if you look at on the right side, provisioning from one single point, operations from single point, and also the SNMP polling, upgrade, downgrade, and also unified logs. Everything is done sitting at one central location. So these satellites can be any of the switches like 4200, 4300. We are not binded actually to have only one kind of switches to provide this functionality. So in the next slide, you can see that there is a lot of deployment scenarios where you can look at from the campus perspective. Either we call it as a I topology, wherein you can have hub and spoke kind of a solution and then provide L2, L3 across the complete network, or it can be a V topology where you can dual home the satellites to two switches in the core, or it can be a ring topology where you can create a ring and provide the same node unification across the network. So there are flexibility is available in terms of deploying the campus network, but the same concept of node unification is applied to any kind of topologies what you try to build on the campus network. And the same what I wanted to say is from the wireless perspective. So today what is happening is it is the same, right? You have a centralized controller and all the access points will get registered to the centralized controller. So that is one of the key things, right? So now everything can be done from the centralized controller. So the APs are dumb, similar to the one which I explained about the node unification, right? The second key uniqueness is the remote office. The remote office means your controller may be in Bangalore and you need some two access points in Chennai. So you can put two access points in Chennai, but you don't need to have a controller in Chennai. This access point can register to the controller and then provide the same capability as if they are in the same building in Bangalore. So what they can do is they can register to the LAN controller and then they can do the local switching between the access points, not going across the WAN to the controller and then coming back to the next access point. they switch among themselves within that building. And also, if the WAN link fails, approximately around 24 to 48 hours, it can work by itself without having any controller connectivity. So this is something unique, which we call it as a remote office connectivity. And also, we have come up with a new solution on the VM, which is known as a Junos V wireless LAN controller. That means you can host this controller on a VM, and then it provides the same functionality as a hardware-based controller. So it provides the same functionality, and it can scale up to 256 access points per one VM wireless LAN controller. Okay. Now moving into simplification. So simplification is the key, right? So we'll just look at how we can simplify the network. So once we look at the simplification, so one is the operational efficiency, management efficiency, and increased responsiveness, and also what we need is a single point of management. So as I explained earlier, we have the virtual chassis wherein you can have 10 switches combined as a single logical switch and manage one single IP address. And another concept what we have brought is zero touch provisioning, ZTP, so that you can put the switch on the rack, and with zero touch provisioning you can do the complete configuration of the switches. And then the third is the SDN, what I explained about the node unification. You can just put the switches in the campus across the buildings, and from the central location you can do the complete management of those switches, right? So that is what we say architectural simplicity, where you can grow, scale, right? And also for the future, provide the agility, flexibility to add more nodes into the network, and then pay as you grow kind of a concept. So if you see this, I don't know whether you are able to see. For an example, if there is a building with 4,000 employees, campus, and 10 buildings across the campus, and 400 users per building. So 4 floors per building. So the total number of managed switches required is 13. Managed access switches required is 10. Managed aggregation switches required is 2. And managed core switches required is 1. Actually, this is the final answer, but once you see the 4 buildings and 400 users, actually the total managed switches should be 124, and managed access switches should be 100. Managed aggregation switches will be around 20, and managed core switches will be around 4. But with virtual chassis and simplification, the total managed switches from 124 reduces to 13, managed access switches from 100 reduces to 10, managed aggregation switches from 20 it reduces to 2, and managed core switches reduces from 4 to 1. So this is the change of simplification what you see when you adapt the virtual chassis of Juniper. So this is something unique. That means don't think that the number of switches will reduce, but the manage touch points to manage reduces to 13 IP addresses, and in access switches to 10, into aggregation switches to 2, and core switches to 1. That is all you need to manage for a 4,000 employees in a campus network. That is how easy it is. That is what I just wanted to highlight here. Okay. And the same when you look at the wireless LAN, it is the same, right? So you don't have to do anything. It is all done automatically. Like you can once you put the APs, it gets registered to the centralized controller. You can have a remote office connectivity. You can do the upgrade without any hitless kind of a solution. And also the unique thing is it can provide you the intelligent real-time spectrum. That means it can auto tune as per the spectrum requirements, looking at the traffic, looking at the network requirements. So this is something unique what we do in terms of the wireless LAN. So whether it is wired or wireless, we provide the same capability of simplicity as a unified network across the campus or the enterprise. Okay. So the next is the complexity of operations, right? So this we know very clearly. So what we say here is that complexity of operations, what we say is that fixing the downtime from management configuration errors is around 80%, right? That is what the Gartner has come out with, and around $42,000 hourly cost of a network downtime and more than 40% resolution time spent in problem isolation and root cause analysis. This is what the Gartner and IDC report says very clearly, the complexity of operations. So this is where the key, where you need to take care in terms of the operation, management and maintenance perspective. One is the reliability, what I spoke about. One is the architectural simplicity, what I talked about. You can make the network so simple, whether it's wired or wireless. And third is the management, right? So that is where I was talking about the zero touch provisioning, where you can provision the complete network with zero touch, operate, orchestrate, and manage. So we have different solutions. I am not going deep into it because I don't have so much of time. Like we have a scripting in Junos where you can do some scripting and provide this kind of facilities. And we have a puppet kind of a client sitting in the switches, so that in data center, if you have a puppet to do the orchestration, then the puppet client sits in the switches and the same puppet server can do the orchestration of the switches, defining the VLANs, defining the ports per VLAN, all those capabilities from the puppet itself. And the third, we have a network director, which is a management from Juniper, which can clearly provide you the end-to-end provisioning, operation, and maintenance capabilities, right? So this is what is Space Network Director is all about. You're seeing on the screen, right? So this is Network Director, where you can completely manage the wired and the wireless as a single management pane, right? Across wired and wireless. And then you can also do real monitoring, flow monitoring, analyze, visualize, completely control the network. So this is something unique where you can have a simplified management for wired and wireless and also do the analytics, monitoring and flow management. I think already it's 4:20. Sorry. Finally, I just wanted to say from the wireless perspective is also as from the Junos Network Director, you can do add, change the access points or the controllers, and also you can automate and do the policy smart pass connect for the BYOD people, right? When you deploy, then you need to have authentication and you need to provide guest access and you need to provide connectivity to the employees and the customers and the distributors. So you need to have a unified for the to have a unified policy for the distributors to the customers. So the guest access, the smart pass, what we talk about in terms of providing access to the employees wherever they go, whether they are in Bangalore, they are in Chennai, or they are in US. So they get the same policy when they connect over the network. So these are some of the key things which we do in terms of the management, reduce the complexity and make it simple and actually provide the IT administrators to manage the network very simple and also not to have so much of complexity built into the network so that when they scale, it multiplies, right? So that is not the case in terms of Juniper solution. So moving ahead, I'll just cover security. Security, one is the MPLS VPNs, what I talked about. That is more coming from the logical separation across the departments and so that they don't see each other and you can define the policies among themselves so that you can have a different policy for finance, different policy for R&D or different policy for the marketing employees and unified access control wherein you can provide the authentication mechanisms using 802.1x and also do a lot of host checking on the devices wherein you can define a policy saying that these are the things which needs to be there in the devices so that they can come onto the network and if something has changed then they should be thrown out of the network, right? This kind of access mechanisms which is known as unified access control and we have a lot of solutions on this. When you connect it to SSL VPN and people logs in from remote locations, we can monitor them and if they are doing something then we can throw out of the network. The unified access control can talk to the SSL VPN device and tell the SSL VPN device that this person is creating problems, so please throw him out of the network, right? These kind of facilities are available on the unified access and today people are talking about MACsec. So what is MACsec, right? I talked about partition, I'll just move. So the MACsec is when you connect over the fiber uplinks, whether it's a 1 gig or a 10 gig, then what happens is the traffic that is flowing over those uplinks are raw data. They are not secured. Anyone who taps it can get the entire data and can be like man in the middle attack, right? So with the MACsec enabled on these uplinks, all the data, all the traffic which flows on these uplinks are secured, encrypted, so that the man in the middle attack, even if he comes and tampers and tries to pull the data out, it is a garbage for him. So this is known as a tamper-proof solution, which is known as a MACsec, which is available on our switches, and this can be deployed across the campus networks, right? So moving ahead, so I have just put one slide in terms of talking about unified communication and collaboration, wherein you have the virtual chassis on the upper side on the diagram with the switches, and then the wireless access points which are connected to this virtual chassis, and then they are dual home to the core switches which are again virtual chassis. So that if you see this, this is so simple, right, in terms of building the network for a campus. But if you see, it is a unified network of wires providing the same kind of reliability, providing the same guaranteed QoS, whether he's coming from a wireless or whether he's coming from a wired, giving the same access control policies for the user, whether he's in Bangalore or whether he's in Chennai, right? And also having the capability to pay as you grow. Tomorrow, if you want to grow, you want to add more number of users, you need to just add switches, connect into this virtual chassis, and then bring up together, and it's up and running with the same policies which you need to apply, right? So these are some of the things which I just wanted to highlight in terms of how easy it is to build a campus network, reliable, simple, and also secured, as I discussed earlier, right? So, so just I wanted to highlight some of the key products what we have. I don't take much time. We have all one new kind of a rack mountable switches, and then we have the complete core switches starting from uh, like aggregation to the core. And this EX9200 is a new switch which provides you the capability of programmable and SDN capabilities available. So this is one of the new switches which we have released, which provides you all the capabilities in terms of the Junos node unifier concept or the SDN concept, or you can programmable switch. That means you can write your applications and load it onto your own applications and load it onto the Junos, integrate it, and then it becomes a part of the Junos and it becomes a part of the network. This is not, we call it as Junos SDK, and it has complete MPLS, IPv6 capabilities, and also the virtual chassis support. So it is across the rack mountable switches to the chassis. We have the same kind of concept which can be made into a two-tier architecture, simple, reliable, and highly secured and easy to manage. Right? And these are the wireless series access points like 321, 322, single radio, dual radio, high density like 532 gives you around 450 Mbps of bandwidth, and then moving from the outdoor like WLA 632, which you can put it on an outdoor and connect two buildings across each other, right? And the same way we have the wireless LAN controllers which can take from 4 APs to 512 APs, and this can be clustered to build around 10,000 APs in a campus network. And one of the things is the Junos VWLC, which is a virtual wireless LAN controller which can be loaded on any of the VMs, and it can scale up to 256 APs. Right? So some of the case studies I just wanted to highlight, wherein American tech company, they deployed the Link and the UC&C solution. So the main key challenges were distributed global force, agility with real-time collaboration, and unified communication user experience. So the solution what we provided was the wireless and the wired, and provided the easy deployment, simple, reliable, and highly scalable with high performance. So this is one of the key case studies. And the second one was about the university, Armstrong Atlantic State University, where there were around 7,400 students. The same kind of mobile devices. They had a lot of mobile devices, and they wanted a wireless LAN primarily, and also they wanted to have the Smart Pass Connect, guest access, access control mechanisms, and the switching solution. So if you see the solution, so with the complete switching, the wireless, the access control, the smart pass, the guest access, everything was provided for them, and to provide a complete unified network in terms of unified policy, authentication mechanisms, and then the reliability and the simplicity. So they saved around 30% on network maintenance cost. That was a key thing what they looked at, right? So there are a lot of other case studies. I think it's time, so I'll just go ahead. So this is the last slide, what our customers are saying in terms of virtual chassis or in terms of programmability, in terms of link solution, what we provide. So even if you look at the F1, Lotus F1 team actually has Juniper in place. You know how reliable, how fast, right? How simple it should be when you look at a F1 kind of a solution, what you need to provide, because it's all in microseconds what will happen in terms of taking decisions. So that is where we score in terms of providing solutions, both at the switching and the wireless part. Okay, thank you.